Right. In this question, what we have to do is we have to find this distance over here using sine cos tan, which we have discussed in the other parts, in the previous parts. So this is going to be P cos alpha, P cos alpha. And this height here, this is going to be P sine alpha, right? Now, this guy is going to be P. And similarly, this guy is going to be P cos alpha, right? So now I have to understand what is my A. My A is P. What is my B? My B is this, right? My B is this, which is this plus this plus this, right? So that would be P plus 2P cos alpha. 2P cos alpha. Why 2P? Because you have P cos alpha here, P cos alpha here. When you add those together, it's going to be 2P cos alpha. So you can't forget this P, which is this guy. Right. Now, we will look into H. We will look into H. What is the H value here? H value is P sine alpha. H value is P sine alpha, which is this guy. And we calculated that from this right angle triangle. Right? Now it's just a matter of putting that into this formula. So area is going to be, A is going to be P, B is going to be P plus 2P cos alpha. Then I put a big bracket here. Then I'm going to divide this by 2. I'm exactly following the formula. And then H is going to be P sine alpha. H is going to be P sine alpha. Right? H is going to be P sine alpha. Now, that's it. So the rest is simplification. So now you can see from here, P and P is going to be 2P. So I can write here as 2P plus 2P cos alpha, and then put a bracket here, divide by 2 times P sine alpha, P sine alpha. Right. So now, when you look into this one, what you can do? You can take the 2P out. We call it factorization. So those things you have to naturally see now, okay, in the future. So you are going to take 2P out. Then it would be 1 plus cos alpha here, right? And I'm going to write P sine alpha after and divide by 2. So I'm going to put that 2 over here so that I can cancel these 2, right? Now, this you can simplify further. P multiplied by P, it's going to be P squared. So I'm writing P squared sine alpha up front. And then this 1 plus cos alpha, I'm going to write after. That's the area. So, what is our strategy here? Our strategy is to find this length, AB length. Why? Because once you have that AB length, you have this. This is already given to you. You can find this using Pythagoras theorem. 3 lengths are known, right? That is a strategy. Now, AB length is not given to you. So you have to find it. What is given to you? P and alpha is given to you in this triangle. What we are doing, we try to find out if there is an angle, your mind should go to sine, cos, tan concept. So suppose this is H, right? So I'm writing a relation having H and P. So tan is the relation will give you tan is the function which gives you a relation between opposite and the adjacent. That we know. Now H value height you can find by cross multiplying. You cross cross multiply P, so it's going to be P tan alpha. Right? So H is P tan alpha now. So this is my first equation. Now I want to use Pythagoras theorem. So Pythagoras theorem is AC squared is equal to H squared plus 3P whole thing raised to the power 2 that. Right? Now you need AC, right? But we will do that later. H squared is going to be P squared tan squared alpha, right? Plus 3P whole thing raised to the power 2. Now what is AC now? AC is P squared tan squared alpha plus 3P squared square root, right? Now, if you know math basics, you consider plus and minus when you take a square root. However, minus is rejected. Minus is rejected here. Reason, a distance cannot be negative. Now, those things you have to write in BCE. Right now, it's okay. Right? So, it is positive. Good. Mistakes. I saw some of you did this. Mistakes. Now, until this point, your answer is right. When you are taking the square root, I saw some of you did this. You simply wrote P tan alpha plus 3P. You simply wrote that, which is wrong. That step is wrong, right? So, I'll give you a quick note on this one. From your basic math, you have to know the difference between these two. P squared plus Q squared square root versus P squared multiplied with Q squared. What is the difference between these two? You should know. If you simplify this one, the answer is PQ, correct. P multiplied by Q. If you simplify this one, this answer is not P plus Q. That answer is not P plus Q. Reason is this plus sign. And the topic is index law. If you know properly index law, grade 5, 6, 7, you know this. So that's why when you have a plus here, you can't write it in this way. Okay, that can be a small mistake, but fix it now. Right, so yeah, we got the answer for AC. Now, if you want this AC answer, which is from here, you can simplify further, which I'm going to do. AC is equal to, now you get P squared tan squared alpha plus you get 9P squared square root. Now, P squared you can factorize. Do you know how to do that? P squared you can factorize. If you factorize P squared and take out from the square root, that would be P. You write tan squared alpha plus 9. Okay. If you don't know this detail, in the next page, I'm going to show it to you because we need to fix our issues, right? So any questions here now? All good, right? Okay. So second note. Suppose you have a squared p plus a squared q squared square root, right? So you need to simplify, right? You need to simplify. What you can do, leave the square root as it is. You can see a squared and a squared here. We can factorize it, take a squared out. So if you do that, a squared you take out, then you get p plus q squared here, correct? Now, you know this in index law, when you have square root something, this means the number to this power, half power of that number. So suppose you have x here, so this is x to the power half, right? So similarly, you can treat this guy. If you do so, you get a squared square root and p plus q squared square root. You can treat it like this. Why? Because you have a multiplication here, like this, right? So you have a multiplication. So square root of a square is going to be a, and then this guy is going to be p plus q squared. So that's the answer. Look at the question. Now, I'm going to find this length using sine cos tan. What we can use? We can use cos alpha, right? We can use cos alpha. Cos alpha is equal to, suppose this is h, right? Cos alpha is equal to h divided by p. Now, how do we know exactly to use sine, cos, tan? We have to use our knowledge and common sense. First of all, we have to know what is the definition of cos. Cos alpha definition is adjacent divided by hypotenuse. Then you need to find this guy. Hypotenuse is given to you. Then automatically your common sense should tell you use cos alpha. From there, you can find h. You cross multiply, which is going to be p cos alpha here. H is p cos alpha. Okay, done. Now, I'm going to take this guy to be y, this guy to be x for simplicity. Right? Now, what I have here, I have theta, I have h now. I need to find this guy and x. Now, if you touch your common sense, it will tell you this is a right angle triangle. Angle is given to you. One of the side is already there. Use sine cos tan again to this triangle. If you do that, so this is for ABC triangle. This is for ABC triangle. If you do that, you are going to have, let's do sine theta first. If you use sine theta, it's going to be h divided by y, right? Opposite divided by adjacent. So from here, you can subject y, which is going to be h divided by sine theta. All good? Now you can do the substitution for h. So y is equal to, your h is going to be p cos alpha. This is going to be p cosine alpha divided by sine theta. That's the answer. Now, if you want to find, right, if you want to find x, what you do, you use cos theta. So cos theta is equal to, okay, actually it is easy to use tan theta, right? I will use tan theta here. If I use tan theta, it is going to be h divided by x, agree? So you need to find x now. X is going to be h divided by tan theta. Now, h is what? H is p cos alpha. So you are going to say x is equal to p cos alpha divided by tan theta. That's the answer. So now for this question, we will use our experience. This BD distance, you can write as P sine alpha. P sine alpha. Now you do that quickly. If you know sine alpha definition, so now your brain is tuned enough to write this one quickly, right? Then this one is going to be P cos alpha. P sine alpha, P cos alpha. Then how much is this then? So you are going to take this big triangle here. You are going to take this big triangle. That would be opposite is there, which is P sine alpha. You need to find the hypotenuse. So I'm using sine theta. Sine theta is opposite, which is P sine alpha. Divide by hypotenuse is AB. Correct? So now from there, you are going to subject AB. That AB is going to be P sine alpha divided by sine theta. Got it. Right? Now, I'm going to find AD now. I'm going to find AD now. Right? To find AD, what I will do, I will use tan theta. What is tan theta? Tan theta is again P sine alpha divided by AD. AD means this big amount. P sine alpha is this. So I'm using this for this right angle triangle. Opposite divided by adjacent. Now from here, you subject AD. When you subject AD, that would be P sine alpha divided by tan theta. Right? What I did was I cross multiplied here and then put this term over here. Okay. Now you need to find AC. So you have to say AC is nothing but now AD, that bigger distance, minus CD, common sense. Right? So AD you have now. AD is going to be P sine alpha divided by tan theta minus CD. CD is going to be P cos alpha. CD is going to be P cos alpha. Right. So now we are here. Now, if you look into this, you can factorize, right? So in this factorization, you take P out, right? If you take P out, this is going to be sine alpha divided by tan theta minus cos alpha, like this. That's it. I have to give a small note here. Some people are confused with this. Sine alpha times sine alpha is sine alpha the whole thing squared. That we know. This is very similar to x times x is equal to x squared. 2 times 2 is equal to 2 squared. Something like that. But in trigonometry, this sine alpha whole thing to the power 2, you write in a special way. That would be sine squared alpha. So you have to understand, this is nothing but sine alpha, the whole thing to the power 2. Right? Now, if you look into our simplifications here, let's see whether we can see something like similar. See, if you look into this, I'm writing tan squared alpha. So that would be tan alpha multiplied with tan alpha. That you should know, right? So theory related to non-right angle triangles. This we mainly divide into two parts. One is sine rule. The other one is cosine rule. Firstly, we'll discuss sine rule. This is the first one we discuss, and this is the second one we discuss. So sine rule. So from the topic, this is applied for non-right angle triangles. So what are the non-right angle triangles? Non-right angle triangles are like this. Right? Something like this. I'm going to get this angle to be capital A, this angle to be capital B, this angle to be capital C. So the sides opposite to that angle is going to be ABC, like you can see in the picture. ABC are length values, simple A, simple B, simple C. These are length values. Capital A, capital B, capital C, these are angles. Length values and angles. Right? So any of the angle is not 90 degrees. Right? So not equal to 90 degree, any of the angle. Can be lesser than that, can be more than that. So if you have this, the sine rule says sine of A divided by the corresponding side length is equal to sine of B divided by B is equal to sine of C is divided by C. So now, if you take this angle, you take the corresponding side length, the opposite side length. That is what you can see here and here. Right? So this is sine rule. So you precisely should know this can be applied for a non-right angle triangle. And this will give you a relation between the angles and the side lengths. Right? Now we will try to dig deep into this and try to understand what are these terms. Right? Consider Sin A divided by A. Just that term. Right? So from here, I'm going to extract sin A. And I'm going to extract simple A. Simple A is a length. Simple A is a length. Now let's talk about sin A now. This A is an angle. A is an angle. A is the input to the sine. But sin A becomes length. Sin A becomes length. So what I'm saying from here, indeed, A is an angle. A is an angle like 30 degrees. But when you put that angle inside sine, the output is a length. A length or a number. Right? So now that is the end of analysis. So now if you look into this sin A divided by A, sin A divided by A, you will understand sin A gives you a number. A itself gives you a number. So this is now number divided by number, possible. Number divided by number. Example, 0.5 divided by 3. 0.3 divided by 0.5 divided by 3. Right? So sin A divided by A, that term gives you a ratio. So this is nothing but now ratio. Right? That is the deep analysis you should be doing right now. Now, if you look into this, now you will understand sin A divided by A is a ratio. This one, another ratio. This one, another ratio. If you understood this to the right depth, you will get this in this way. Sin A divided by A can be 1 divided by 2. Sin B divided by D can be 2 divided by 4. Sin C divided by C can be 3 divided by 6. All are equal to each other. No magic here. Right? So now this is all about sine rule. Now this sine rule is a relation between the angles and the side lengths. Make sense? Okay. Now I'm going to extend this knowledge into this. We understood that sin A divided by A, sin B divided by B, sin C divided by C is a ratio. Is a ratio. Right? So ratio is like 1 divided by 2. So if you write 2 divided by 4, still it is 1 divided by 2. So this one 3 divided by 6, still it is 1 divided by 2. Right? So this you can equate knowing that's a ratio to a number like half. So in general, I'm going to say K. Does it make sense? So all of these are logical. Try to catch this logic through common sense. So this is going to be equal to K now. Now I would say for this system, K is a constant. And what K tells you about the number when you divide these two. K tells you the number when you divide these two. K tells you the number you divide these two, where K is a constant. Now we understood sine rule to be this. Sine rule is nothing but the ratio between the angle value and the corresponding length. Right? I'm going to tweak this problem a little bit and see whether that makes sense. So the sine rule The typical sine rule, what we introduced is sine A divided by A, sine B divided by B, sine C divided by C is equal to K, right? Can you write this relation in this way? A divided by sine A, B divided by sine B, C divided by sine C is equal to alpha. Can you write this relation like this? Can you write that? Answer? Answer? No, you cannot. Right? What is the answer? No, you cannot. Understand? That's your fault. So answer is yes, you can. What we are doing here is what is the difference between this and this? Logically, both are the same. The whole purpose of sine rule is to get the ratio. To get the ratio. That ratio you are writing this way or that way doesn't really matter as long as you are maintaining that. Right? So also, this alpha is nothing but 1 divided by k, because what you do is you take the reciprocal. So that reciprocal value 1 divided by k, you can rename it as alpha. So indeed, this is possible. So when you read books, when you do questions, when I'm doing questions, you will see that sometimes I write the sine rule in this way, sometimes I write the sine rule in this way. Doesn't really matter. I'm talking about the same guy, right?